Okay, in this quick video I just wanted to share some of the objects that I've obtained from Shapeways, the 3D printing company, recently. First up we have this Mobius net, it's called. It's this very organic looking structure that seems to float in on itself. It makes me imagine coral and other structures like that. But this is really in itself a mathematical object, a mathematical curve that they've managed to 3D print. It's quite a fascinating shape. Next we have this hypercube. This is like a squashed hypercube projection. So if you imagine a four-dimensional hypercube projected into a three-dimensional space, to cast a shadow in a three-dimensional space, this is the structure that you would be left with. This interesting object called gyro, the cube, four cubes nested inside one another, each of which can rotate independently. So you can play with that for quite a while. And again, these were 3D printed separately and then assembled. But yeah, you can all rotate independently of one another. Next up we have this mathematical object called a 120 cell, and you can actually see straight through the middle there on any face you choose. Incredibly complex but structured and ordered object, just printed in the white plastic option here. Lots and lots and lots of pentagons, all nested one inside the other. And we have this Mobius band. This is printed in alumide. It's like a plastic print with aluminium dust or powder. If you can imagine a rod with a square cross section folded in on itself to form this circle, but then given a half twist, and so it doesn't have four edges, it has only two edges because they curve in on one another. It's an interesting Mobius structure. Also in alumide we have this basic fractal. It's called a Menger sponge, and just a couple of levels of iterative patterns there that you can make out. Again in alumide. Then we have this basic DNA structure, the model of the DNA double helix, with a major groove and a minor groove. That's how, obviously not atomically accurate, just structurally accurate with the base pairs and the DNA groove itself. And we have this model. This is a gyroid. This is a purpley style plastic. This reminds me of a sponge that you might find in the ocean, and if you look at it certain ways you get different arrays of 6 kind of holes through the middle of it. There we go, there's another view of the 6 holes. Your finger kind of naturally wants to go and explore this surface. And that itself is a interesting little shape. And we have this model, which is, I've decided to get this printed in black plastic. This is a model of a carbon nanotube, and this is what one of these molecular structures might look like. It was blown up. This is just a ball and stick model, of course. You've got the little hexagons there with each little sphere connected to its neighbours, making this material into all sorts of things, from computing to memory to textiles, energy applications, energy storage, all sorts of things with this wondrous little carbon nanotube material. Closely related is this buckyball. It's a model of a molecule of Buckminster fullerene. 60 carbon atoms in total. It's shaped like a classic soccer ball shape. Again, done with a 3D print. You can see the pentagons there surrounded by hexagons to form that spherical structure. These again have been used in a range of scientific applications. using these in next generation memories, also as lubricants for micro machines and other structures. We also have these 3D printed mazes. So this little point here is the start of the maze, and then the object is to roll that little ball out through the exit, which is in this corner here, and you've just got to try and move that around until you can find the pathway out. It also comes with these smaller ones as well, basically work by the same principle, but the smaller ones are a bit easier than the other ones. And we have this structure. This is called a Hilbert curve. Again, a mathematical object, but what I like about this is you can deform it into various ways and it still wants to go back into its original cube-like shape there. And this reminds me of DNA origami, where you'll synthesize complementary strands of DNA sequences that, when mixed together, will self-assemble and form arbitrary two-dimensional, three-dimensional shapes. So you could imagine that each of these rods is a strand of DNA that has been programmed to self-assemble into this cube-like structure, and indeed any arbitrary shape that you might want. Then we have this model of a bacteriophage. This is a model of a virus that infects a species of bacteria. In the real world, this would all be made out of protein, the whole lot. You have these little legs that would act like, that particular structure would act like a key that would target a specific species of bacteria's receptors on their cell walls. That would be like the lock, and when it attaches to the cell wall of the bacteria, these legs would contract. This shaft would be thrust through the bacterial cell wall, and the DNA inside the head here would be injected into bacteria. Bacteria would then produce hundreds of thousands, if not millions, of copies of these viruses. It would then rupture, and the offspring would be set to go and repeat the process. And all of these structures have been 3D printed with plastic powder and a laser. So the basic process is they lay down a layer of plastic powder, a laser comes along and maps out the first slice of the 3D model from the computer. Another layer of plastic powder is laid down, laser comes along and does the next slice, and so on and so forth. And so you build up your whole 3D model, whole 3D structure, layer by layer, slice by slice. And the resolution from these Shapeways 3D printers, quite good. Is this amazingly intricate little structure. So what we actually have here is 2 layers of 4 cubes, you can see inside there, that are nested within 3 layers of 9 cubes. And your fingers can just play with this for ages. So this was done in a single 3D print. In the printer you would have picked this out of some powder, got rid of the excess, and you'd be left with the structure that you wouldn't be able to manufacture in any other way. And yeah, this is just amazingly intricate little structure. We also have this is called a linked Voroni. This is quite a delicate ball-like structure. It does bounce a little bit, it's very light. Just roll, and if you can look in, it's got this funny pattern. Again, it looks very organic. It's very flexible, but it is delicate. I have broken a couple of the little linked arms. You wouldn't be able to make this any other way. It kind of gets your imagination ticking over with what might be possible, and that's the main reason I went and acquired these intricate little structures to begin with. There's no real purpose to them. They look interesting, they certainly feel interesting to touch, and I guess the main reason I went and acquired them is that they kind of expand your imagination with what might be possible with this 3D printing technology. Also gives you ideas with what you might also like to try yourself, what 3D objects and structures you might like to create and use. And yeah, I just find it really useful as a creative aid. Gets your mind ticking over, and everyone I've shown these shapes and structures to has been just blown away and amazed that you can actually do such things. Alright, cool. Thanks for watching.